We're going to find the flux of this fella. And we know that it's a triple integral over a solid. Did I call the solid D or E? I want to be consistent. I think I called it E yesterday, didn't I?
Yeah, I'm pretty sure we went with E for...
Well, we'll call it E, just to be consistent then. So the triple integral of a solid, and then it's a divergence and a dV. In this particular case, they describe the surface of the solid, but if you describe the surface, you are essentially describing the solid. So it ends up being that guy, which is a cylinder, meeting up with this guy. And I deliberately chose this one because it was an easy one, and I figured that I won't screw up so much if they're easy. If you take this particular shape, would you agree that the x squared plus y squared especially is an indication that cylindrical coordinate scheme would be the best way to describe D, or E, I should say. So x is going to be r cos theta. The y is going to be r sine theta. And the z is just basically going to be z. In this world, because this is a circle of radius 2, the r value will go from 0 to 2. We'll get the entire circle, so we'll do a 0 to 2 pi. And then this fella here is what made it easy. Can you see that they're essentially telling us the boundary for z? Are we good?
Wouldn't that x have to be converted into r cosine theta?
Yes. And so will, oh, I haven't even got the darn question yet. I forgot to tell you who f was. In this question, you're told that f is an x to the 4, a negative x cubed z squared, and a 4x y squared z. I guess I could do it right now. Probably would be a good idea now that you've mentioned it. You okay about the x becoming an r cos theta? Okay, so to get the flux, the surface area, the divergence theorem says that we need to do a triple integral, which we're about to do. The theta can go from 0 to 2 pi. And the r value is going to go from 0 to 2. And the z is going to go from 0 to r cos theta plus 9. The divergence, okay, if you take this first guy, differentiate him with respect to x, I believe you get 4x cubed. If you take this second guy who's q, and you differentiate him with respect to y, you don't actually get anything, it's 0. And if you take this guy and do it with z, you get 4x squared y. And the whole thing's going to be over a dv. Well, we know what we're going to be doing here. It's going to be an r, dr, d theta, dz. Well, that's not technically the right order, but I'll fix that on the next line. So it's going to be 0 to 2 pi, 0 to 2, z equals 0 to r cos theta plus 9. I don't think there's much point in pulling out a common factor. You're still going to have to deal with the other stuff. Well, actually, these two guys have to be turned into that fella. And this fella is going to have to be turned into r squared cos squared theta, and this guy is going to be turned into r sine theta. I put the r here, I'll put the dz, then the dr at d theta. Don't know if you can read it, but it's r z first, r second, theta last. Is there anything going to nice come out of this? Oh, I think I could try one more line just in case we get lucky. You got 4r cubed cos cubed. That r will join this, and you'll get a 4r cubed cos squared theta sine theta. And then I realize there's another r here. So basically these two guys turn into 4s. And then I have a dz, a dr, and a d theta. I don't want to do any more. This is just growing horrible. But I can tell you something that's nice. None of those terms contain a z. So won't the integral just be all of that with a z attached to it? Now that is going to be really ugly, because that means you're going to take this and multiply it by that. And then you're going to do the r's, and then you're going to do thetas. Well, I originally thought it was going to be a nice question, but it kind of grew into a monster.
Professor, could you check the waiting room?
Can I check what? Say that again.
Waiting room.
Oh, thank you. Yeah, I'm glad somebody's doing that. Yep, Patrick wants in. Okay. You just got to live with this ugly one. It looks like it's growing into a monster. You're just going to be dealing with r's, and well, I guess at the end you're going to be dealing with this guy, but this guy would be a u sub cosine theta, and you're going to be dealing with a cos cubed. Oh, maybe I should talk about that then. Well, forget about the multiple. There'll be some number, 820 there. But you're going to have to deal with some multiple of this guy and this guy. Right? In this one here, I've said, look, a u sub equals cosine theta is going to work on it. Cos cubed theta, got to tackle that differently. Got to do something. It's not maybe obvious what you got to do, but you got to do it. What will I rewrite cosine cube as?
Cosine times 1 minus sine squared.
Oh, you did the whole thing in one go. Well done. And the reason why that's a good idea, well, can't you do a u sub of sine theta? And then you can get your answer. So that looks to me like it's going to be like a 20-minute question. Thankfully, there's not that many of them. Any problems with that one? Are we good? I'll wait a second because I know some of you are still writing. Okay, just going to pause this for a second. Show you what's going on in the homework. Okay, question 13, which I'm not doing, but if you look at question 13, have you noticed that they tend to give the vector function in the IJK notation? Yeah, every question I do, I use a little, bracket thing, so it's just cosmetic. Would you agree this one is simply 0 to 2, 0 to 1, 0 to 2? So you're going to use X, Y, Z. Not an issue with that. Boxes are nice. If you had to do that the old way, you'd actually have to do 6 surface areas, which would be horrendous. Here's just a different way of describing a box. X is going to go from -1 to 1, Y is going to go from -3 to 3, and Z is going to go -1 to 1. Now, if you're doing a triple integral and everybody's a number, that tends to be pretty straightforward, doesn't it, from if you've done any yet? Right, you've just got numbers for each one of the limits of integration. So I don't feel I need to do that one. I think I'm going to do 15, which is this guy. Before I start 15, pretty standard polynomial, right? Nothing too fancy, so its divergence shouldn't be too ugly. I have an x squared plus y squared minus z squared is 1, and I have z going from -1 to 2. Now that one might look like it's spherical. In fact, if it had been x squared plus y squared plus z squared equals 1, I may well have went spherical coordinate system as well, right? Because that would have been a sphere. But because it's a -y squared, that actually is going to turn into a get the word out, cylindrical coordinate scheme. Let's talk through some more. Here is a pretty standard polynomial. This time the surface, which is going to be our volume, is x equals 0, y equals 0, z equals 0, and then this guy. Actually, I think I'm going to do that one first. Because now I've looked at it, it's more than I thought it was going to be. So if you can say hi for attendance right now, I'll get this thing set up. So it's x squared y, xy squared, and 5xyz. And then it's this tetrahedron, which is some weird kind of dice shape. It's bounded by x equals 0, y equals 0, z equals 0. And then it's got this fella. Right. See what on earth that solid looks like. Do you know these 3 guys are basically telling you it's in the first octant? Because it's the plane x equals 0, not the line x equals 0, but the plane x equals 0. And the plane x equals 0 is actually the yz wall. And y equals 0 is the xz wall. And z equals 0 is the floor, the xy one. So can you imagine that you're looking at the first quadrant, right, at zeros, and then you've got this fella. So if you can imagine, and I'm probably going to regret this, but I'll try it anyway. This is a plane in 3D. Cuts the z at 3, cuts the x at 3, and cuts the y at 1. Now, if you add to it the 3 walls, right, the floor and the 2 side walls, can you see that tetrahedron shape that they're talking about? It would be a shape that kind of looks like that, right? Which means our first job is to figure out what E is for the solid. Agreed? Now, I'm not going to use cylindrical, certainly not going to use spherical. I'm going to use X, Y, Z. I think it's pretty obvious that based on this information, that's the only coordinate system that's going to help. And if you imagine this line here on the floor, and then you orientate it kind of by swiveling it, what you've got is this plane meeting the floor, which means you're looking at Z equals 0. And what does that look like? Well, doesn't it look like this guy here? So with a change in orientation, can you see the floor as this guy? That is going to allow me to do my little vertical rectangle guy. And I'm going to be able to say that X goes from 0 to 3. And that Y is going to go from 0, right at the bottom, to whatever the equation of that line is. Now, if you've done enough equations of lines, you start just doing it in your head. Would you agree this guy has a y-intercept of 1 and a slope of negative a third? If you put that package together, can you see the equation of the line? Negative 1/3 x add 1. I'm just trying to get the answer quickly, right? Without going through, various techniques that you might have learned from Math 99. So from the bottom to the top tells me that this is the range of that guy. Now I need a range for Z, right? Z's got to start here and finish there. Agreed? Now the guy that's going to tell me that is this fella here. Agreed? Now, on this side, I'm going to do Z equals 0. Why? Because of that. And if I rearrange this, you get 3, take away an X, take away a 3Y. Are we all happy about the setup of how I created this from that information? Any questions about that? Okay. So our flux is going to be a triple integral, just because I want to. X is going to go from 0 to 3. Y is going to go from 0 to negative 1/3 x plus 1. And Z is going to go from 0 to this. Now in a few moments, I'm going to put the divergence in here. Hopefully I'll leave enough room. And I'm going to go, and that's going to be the dV. Why is that the only correct answer to the limit of integrations? What makes this first? Sorry, keep going.
That has both x and y's in the integral.
So it has to be done first, right? And this one has to go second because it's got
x's.
It's got x's, and this goes last because it got numbers, right? Now, if you've got numbers, if there's two guys with numbers, let's phrase it that way, if the x's had numbers and the y's had numbers, couldn't you switch places and it wouldn't really make any difference? But if there's a variable of any kind, then you do have to be a little bit more precise about the order in which you do your calculation. So that's the order for this one. Now, if I do the div of this, differentiating this with respect to x gets me 2xy. Doing this with respect to y gets me another 2xy. And this fella here gets me, what, 5xy. So it's going to be from 0 to 3, from 0 to negative 1/3 x, add 1, and from 0 to 3, take away x, take away 3y. And since they're all the same, it's 9x. Why? First you do it with z's, Then you do the answer with y's, and finally you finish off with numbers. And that's as far as I'm going to take that question. Are we good? Did we got a thumbs up? That's the way you would have done it. That's a good sign. The last one I'm going to do today is the spherical one because there is lots of thumbs up. Because I think they're only one. There might be two, but there's very few anyway. Let's go back and do. I think it was 15 I was going to do. Right. Let's see. The vector function was x cubed y minus x squared y squared minus x squared yz. The solid is built by that guy, which evidently is a thing called a hyperboloid. I have no idea what that looks like. And z goes -2 and z goes 2. Okay, for this question, we have to fix E, right? The solid. I'm going to go cylindrical because of this fella. So how's that going to work? Well, x is going to be r cos theta, and y is going to be r sin theta, which is fine. But now we have a pretty major issue. What does this guy look like? Well, you normally put it on the floor, right? Because that's kind of typical. In other words, you make z 0. But in this world, we have this fella going on. And that does change a little bit anyway. How we're going to figure it. Oh, darn it. I should have looked at the answer earlier. I was just about to do a whole load of clever work. I was about to put 2 in here, get -4, bring this over in 5, and that would tell me it was a circle x squared plus y squared equals 5. Does anybody know why I didn't need to do any of that?
Green's theorem, it's a thing.
Oh, conservative field, it has a divergence of 0. I haven't looked at the solution. If the divergence is 0, and I think I said this yesterday, didn't I say, find the divergence first, just in case. And then I go and tell you to do it, and then I don't do it. See, that's Murphy's law. I should have done that first. If the divergence is 0, does it really care what E is? Nope. Because won't E be 0? Because it's a triple integral of 0. And 0 dv, whether you use x, y, or z, or any other coordinate system, is going to be 0. So that fella do you need to check it? Can you just trust me that if you do the differentiation, it ends up being 0? Right, okay. Let me go hunting for another guy. See, I clicked on the solution in that one, so that's why I didn't know it. If you hold on a second, I am going to go and put in the answer. Oh, that's much better. Oh, the BBCs. Okay, gotta show you this. I'm going to make another question up to compensate for this, but I've got to show you this. question 17 was the only question that I was going to do where we would use spherical coordinates, and it's pretty easy if you look at it. It's that guy there. Yet the answer is 0. And the answer is 0 because, pardon me, this fella has a divergence equal to 0, evidently. Darn. I'm assuming that's what happened. Okay, well, we got time. I get time for one other one, and then I'll make up a spherical coordinate system that isn't 0 so that we can all see it being done when it's not 0. That should be fun. We done a tetrahedron a minute ago, didn't we? So I'm not doing that one. That was the one I tried to do. I'm stuck. Okay, let's go for it. I'm going to put a health warning on this question because since I am making this question up from scratch, the chances are that it's going to come out pretty and smooth are very unlikely, right? But let's go for it. Let's suppose we have a vector function and it is x squared, y squared, z squared, because I don't want to take any chances. And the surface, in other words, the solid that we are looking for is x squared plus y squared plus, well, plus z squared equals 1. Do you think I have got a fighting chance that this might be a nice answer? So basically, this is your vector function. The solid is a sphere, right? A ball centered at the origin radius 1. That's good. I'm taking no chances by finding the divergence first. Which is relatively boring, but at least nothing scary. Now, since I'm using spherical coordinate systems, and I'm taking no chances with that either. Can anybody remember what, you know, like r, dr, d theta, dz, that's cylindrical, what the ugly thing for dv is? I've got it in front of me, but does anybody know it?
Rho squared sine phi?
Yep. And then you basically just do d rho, d phi, d theta, and they may change permutations. That was pretty good. What's x equal to?
Isn't it rho cos theta?
No, you've got me guessing now. I thought they had to define it. I'm
Is it phi?
not relying on my memory.
It's rho cosine theta sine phi, I think.
That sounds better. I'm just going online right now and getting, which is what you would do in a test, right? It's written. Where have we got it here? Wikipedia's got it. Hopefully they're not telling me lies. They're doing all sorts of weird stuff that I don't want to see. That's cylindrical. Oh, okay, that was a bad choice. Let's do Wolfram, they should be nicer. Here we go. And you were correct. It is cosine theta sine phi, and then it's rho sine theta, sine phi, and then it's, whoops, it's rho cosine phi. Right. So if you ever get stuck, if you knew it was going to be spherical, this is the guy you would use, right? So I should be able to put this package together. Well, for a sphere, where I put it down here. Because it's a unit circle, rho goes from 0 to 1. Theta is basically rotating around the xy axis, so that goes from 0 to 2 pi. And the one that sometimes people forget is that this one is not 2 pi. Great? 0 to
Pi.
Pi.
pi. Right, so that one's looking relatively nice. Let's try and put the whole package together then. The flux, the surface area, is going to be, well, all the numbers are good, so I can technically do it in any order I like. So let's do phi from 0 to pi. Let's do theta from 0 to 2 pi. And rho equals 0 to 1. And right now I'm going to call it 2x plus 2y plus 2z. And I'm just going to call it right now dv. But what I'm really saying is it's this guy, right? So that now gives me some room. 0 to pi, 0 to 2 pi, 0 to 1. 2 times this fella, plus 2 times this fella, plus 2 times this fella. And I don't have enough room, so I'm just going to have to call it dv. Yeah, it just did kind of grow into a monster. Right, dv is basically all of this bit here. So all of these terms here, this one, and this one, are going to get multiplied by the guys. So I'm just going to do, well, I'll tell you what I could do. Can I pull out a 2 rho? And that gives me a cosine, a sine, a sine theta, and a sine. And then I can finish with just a cosine of theta with that guy. Oh, God. Rho squared.
I think it's cosine of phi, not theta.
It is. Well got. There we go. And then I'm trying to figure out, is there any pretty things I can do to this? And I think I'm reaching the dot, dot, dot stage. Would you agree this would just take forever in the day, but it's doable? Yes, Ben.
I thought about some more and realized I was wrong. I'm sorry.
Okay. I don't really think I can do too much. Oh, after saying that, there is a little I can do. Do you know that rho squared thing that would be here? If I bring it with this one, I can have 2 rho cubed. At least I can separate out the rows. And that means I only have to do a double integral of everything else that's left, which is d theta, d phi. Right. If you take this and match it with that, you get 2 rho cubed. Right. So I can at least separate the rows. That's not going to do me much good, but at least it's something. These two guys here are too mixed up, I think, for me to do any separation. So I'm going to have to do one followed by the other. But at least I have numbers like zeros and 2 pi's and zeros and pi's. So I wouldn't be too surprised if there are a lot of zeros and ones floating about in that. But there, finish with a dot, dot, dot. Are we good? Thought just came to me. We've been calculating these for, seems like forever. So it's obvious it's big, important thing. We got a couple of questions. I think there's 3 altogether, where the divergence ended up being 0, which means that this answer is 0. Agreed? Because it's equal to a triple integral of 0 dv. And it really doesn't matter what the surface is, because wouldn't that make the final answer 0? Doesn't matter if I do it polar, don't matter if the shape ends up being cylindrical or anything, it's 0. So the thought that's came to me is the divergence of f is 0 implies that this thing is 0, right? That the flux is 0. Does it work the other way? If the flux is 0, does that guarantee that the divergence is 0? Or could you get a flux of 0 from a vector field that didn't have the property that its divergence was 0? I don't know the answer to that question, but it's a thought. If a flux of 0 means everything that's coming into the surface is balanced by what's leaving the surface, right? That's what a flux of 0 sort of means, right? All the stuff coming in is balanced by all the stuff going out, right? What's your gut feeling?
It is possible.
It might be true that both directions work, or it might be possible that there's some vector functions out there with 0 flux, but not have a divergence at 0. My gut feeling that I'm thinking about it is, I bet you it's possible. Right? Can you imagine all the vector functions in the world and all the surfaces in the world? If you were really clever, couldn't you figure out a surface that would balance the ins and the outs? You know, expand it a little bit, push it in here, shove it up there. Maybe a weird looking surface, but I'm assuming it is possible. And we should finish Calc 4 on a thinking question, and that was it. We are done. There is nothing new. Everything that's covered. I put a video out to try and cover my lack of curl. Evidently, I forgot some curls. And so I put a previous video. Hopefully, I also put a PDF, and you'll find it on Canvas. So you'll see some examples, maybe to make up for that. So hopefully that didn't cause too much issues. What else? Tomorrow, revising for the test and the final. Monday is the test. Anybody who feels they don't need to, I'll repeat that. If you don't need to do the test because you're good and you're happy with your grades, then that is fine. Over the weekend, because I started it, and God, I didn't realize it was going to take so long. So next time I'm going to figure a better way of picking up attendance. So sometime over the weekend, probably by Sunday, I'll be sending out an email that will say, I believe you've attended this number of lectures.